Hello everyone and welcome back to the Nerd Cave. Over the past few months I have made a few macro keyboards here on the channel and also published guides on my website on how to make them. And today we are going to build a brand new macro keyboard together, but this is going to be a bit different than my other videos because this one is going to be a mini course where I'm gonna go in so much detail that you know how to build a macro keyboard. So this is going to be broken down into 3 parts. In part 1, we will look at the scope and design of our macro keyboard. This will then help us to decide which components to use, and then we will look at how to set it up. Then we will move on to the prototype and we will create a simple version of our macro keyboard on breadboard. After creating the prototype, we can then write the code. In the second part, we will look at designing a PCB for our macro keyboard and also designing an enclosure. In the last video we will then assemble everything and then we can go write the final code for our macro keyboard. So let's then get started with part 1. Before we talk about the components or even the design, let's first make a scope of our project. So what do we want our project to have? Now I was thinking we can make a macro keyboard that will have at least 9 buttons, whereby only 8 of them will be usable, and we can leave 1 button as a way to change the different modes we are in, so the different programs. And then to display the mode, we need to have some type of display that can show which mode is currently active. And one added nice feature will be to have one rotary encoder that we can use with different programs that can be used for scrolling through the timeline, for example, in Premiere Pro. So this is the scope, and so let's go and look at different designs. Now in terms of a design, there is so many possible ways we can design our macro keyboard. Here on the screen I have 5 different types. Now I know the design is going to heavily impact your PCB design and so on. So here you're going to have to be careful on your type of design. So far all the designs I have made, I've only used a 10x10 PCB, but I want something a little bit more unique this time. So using these type of designs, I think I'm going to go make my own sketch of a design in Sketchbook. Now also this program I'm using here to show the images is called PureRev. I will put the link in the description. It's a nice way for you to use a lot of images as reference when you work on a project, as well as Sketchbook is free as well. So let me quickly go make a sketch and I'll be right back. So for the design of the macro keyboard, I came up with the following design. It is a bit different than my previous projects, so I think we're going to stick with this design for now, and later on if we need to make any changes we can. So let's talk about the electronic components we will need to build our macro keyboard. The first thing we will need is some type of push buttons to build a prototype, and we will use this 8x8mm push buttons along with a breadboard. The breadboard will allow us to make a prototype by putting the components in a breadboard so that we do not have to do any soldering. For the final version, I'm just going to use these mechanical switches. There is a lot of different types of mechanical switches online, so you're gonna have to do your own research to find the best key for you. We will also need some wires when making the connections on a breadboard. For the screens we have a lot of options to choose from, but I'm going to go for this popular OLED display, the SSD1306. For the rotary encoder we will use this module that comes on a PCB that will make it easier to connect to the breadboard. And then on the final version we will use this rotary encoder with a few resistors that will be mounted on our PCB. When selecting a microcontroller, some microcontrollers can act as a human interface device, and this will make our life a lot easier. A human interface device is just a standard of communication between an input device, computers or other devices. So in very simple terms, if we plug in a USB to a microcontroller, our computer will then see it as a keyboard. Here we have different microcontrollers that we can use for our project. So let's discuss some of them. This is the Arduino Pro Micro, and it is based on the ATmega32U4. This microcontroller is popular due to its ease of use, built-in USB support and small form factor, and it can easily be programmed using the Arduino IDE. Another popular and wide used microcontroller is the ESP32 and ESP8266. These are very popular microcontrollers as they can also be programmed using the Arduino IDE, or you can put firmware like MicroPython or CircuitPython on them. The microcontroller I'm going to use is this RP2040 board from Waveshare, which is the same as the Raspberry Pi Pico, but this one has a small factored form. So this in short is all the main components we'll need for a macro keyboard. A detailed list of all the components will be given on my website for a prototype and main macro keyboard that will be done on a PCB. So now that we have selected our microcontroller, let's quickly look on how to set it up. The only problem with this microcontroller is that we cannot connect this to the breadboard due to its pin layout. But since this is using the RP2040, we are going to use the Raspberry Pi Pico that we can connect to the breadboard. So the setup for both of them will be the same. In the second video when we make a PCB, there should not be any issue, as the GPIO pins and everything would stay the same for both of them. Let's set up our Raspberry Pi Pico. The first thing we're going to do is we're going to take the Pico, we're going to press and hold this boot cell button, and then we'll plug in the USB, wait a few seconds and then let go. Your Raspberry Pi Pico will now show up as a mass storage device, and it will show RPI-RP2. Now head on over to my website nerdcave.xyz. There will be a link in the description, and go under Raspberry Pi Pico and click on Get Started. Then go to Tutorials and go to Macro Keyboard. This will be more updated as later as I go through the course, but for now we just want the CircuitPython firmware, which we can download here. So just click on Download and go save this on your computer. Now all you have to do now is take that file, copy, or drag it into your Raspberry Pi Pico's mass storage device, and this will then flash it with CircuitPython. Your Raspberry Pi Pico will then unmount, and it will mount again, and this time it will still be a mass storage device, but it will show CircuitPython. Now that we have our CircuitPython set up on our Raspberry Pi Pico, we can then go and build a prototype. I have made a circuit diagram in Fritzing to show you how to do all the connections. I'm also just going to give a short overview of how you will make these connections, but it is very straightforward. We will start with our breadboard, and we want to plug in a Raspberry Pi Pico here in the middle. So we'll just snap it in place like this. So we will have 2 columns here and 2 columns here. Now we just need to go place 9 buttons. When we push the button here in the breadboard, you just need to make sure that there is a gap between the 2 legs. So let's go place all 9 buttons. We will use the first 9 GPIO pins on a Raspberry Pi Pico. So starting with GP0, we will just plug in a wire there, and then plug it in here at the button, and we'll use this top leg. Now these 2 legs here on the top are connected to each other, and the 2 bottom legs. And let me quickly show you with a multimeter. Here we have a multimeter, and we're going to go test the connectivity of these buttons. So you'll see if I touch these 2 probes, it makes a beep sound. So if I connect this to the top one and the top one here, you'll see there is a short between them. But here at the bottom, there will be nothing. So when we press this button, then this electricity will flow through here, through the button, through this leg here. And we're going to connect all of these bottom legs to ground. Here we have all the buttons connected. Now some breadboards do have a gap here in the middle, so I just made sure to put a wire on this ground rail from there to there, so that all of them are connected to each other. So we still have to go connect this ground to this rail here. So taking a wire, and we know pin number 3 here is ground. So let's just go connect this one like this. Now all the buttons should work. So let's just quickly maybe go to CircuitPython and write a short script to see that all of these buttons are working, and then we can do the other connections. Here is a short script to test the buttons. I will put this code on my website. Now remember, to connect to the Raspberry Pi Pico, you need to click here in the right corner in Funny and click then on CircuitPython. So let's quickly run this code and see what happens. So now it says button test started, and then press any button. Now if you go back in time, you will see this one was missing a wire completely, and that there was a connection problem here. But now that the script is running, let's go test the buttons. So you'll see if I press button 1, it will say button 1 pressed, and I will just do this for 2, 3, 4, 5, 6, 7, 8 and 9. So we know all our buttons are working. So let's go and connect the screen. Now let's connect the OLED screen. You have to be very careful because you'll see here we have VCC ground, and in some OLED displays these two will be changed, so it will be ground and VCC. So make sure to look at the one you have. So the VCC we will connect to 3.3 volt. So I'm going to take this one and connect it to the positive rail here. And then we'll see the yellow one here is going to be my ground, which I can just connect here to ground. Then I will have an SDA pin, which we said is going to be this bottom pin here. Just go look at the schematic diagram. And then the last one, the SCL, will be the one above it. Okay, now my screen is connected, and all I have to do here is go connect the 3.3 volt rail to the positive rail here. And this will be the fifth pin from the top. So 1, 2, 3, 4, 5. This one here, and connect this to this. Okay, so now our screen is connected. So let's just go and test this again in Funny. For the OLED, we are going to need some libraries, and I have included all the libraries you'll need for this macro keyboard, which you can download on my website here. So click here on download and then go save the libraries to your computer. After you have downloaded this file, go and copy all these files inside. This will be the libraries we're going to use. And then go back to your storage device, which will show CircuitPython, and go paste this in the folder library. Under the library on the website, there is some demo code for the OLED, which you can go and copy here, and we will go paste this in Funny. Later we will discuss this in more detail, but just in short, here we are importing all our libraries, and here is the SSD 1306. Then here we will release the display that might be in use, and here we set up our I2C for our OLED, and then we initialize the OLED display. And then here we have a splash that will allow us to display IO group and display.show. So this makes the display context. So here we will draw with the text hello world. So when we run this, we get the following on the screen. The last thing we need to go connect is this rotary encoder. So just check the diagram and make all the necessary connections. On my website there is demo code for a rotary encoder. So again, just copy this code and go paste it in Funny. So in this code, we go to find the GPIO pins according to our schematic diagram. And then here we set up the rotary encoder pins. Also, we have an extra switch or button we can use with the rotary encoder. And then here we initialize the variables. So to see what is the previous clock value, and we have some counter here. And then we print here rotary encoder test, and here it will test which side it is turned, is it clockwise or anti-clockwise, and it will show a value. And we will also test for a button press. So running this code, we get the following. So now we have the code running here, and you'll see if I turn it clockwise, it will show clockwise and it will change the counter. And if I turn it anti-clockwise, it will add one and show counterclockwise. And if I press this button, it will say the switch is pressed. Now that we have a working prototype, we can finally go and write some code and turn this prototype into a real macro keyboard. To create a macro keyboard, like we said, we need an HID library, and Adafruit has a very good one. So this one is already included in the library that you already have copied to the CircuitPython, and you can see there's a lot of examples here. So here's an example for an HID keyboard and key code, and how we can send different codes. Here we have for a mouse, we don't need this, and here we have for consumer control. And you will see here, if we go to key code, here's all the different key codes that we can send with our macro keyboard. So if you're making a macro keyboard, I highly suggest that you go read through this documentation here. You will find also useful examples to see when we have pressed a button and also when we have released a button. So for example, here when we increment the volume, we might want to press the button and hold the button in to keep incrementing it until we leave the button. That way we don't have to constantly press the button. The code for a prototype is available on the website. Just go to prototype code and copy this and paste this in Funny. So here we have the code for the macro keyboard, and we are going to go through all of this code together. So what I think will be the best is if we break it down into code snippets, and I can explain in detail what each line of code do, or maybe a section of the code. We first start by importing all the libraries that we will need. And here is multiple libraries. The first one is board, which will provide access to the pins for the microcontroller. We also import the bus IO. This is used for I2C communication. We then have display IO, a library for managing displays in CircuitPython. And then terminal IO. This will provide basic terminal font for text display. We then import the Adafruit display text label. This is used to create text labels on the display. And then we also import the library for our OLED screen. We then have our USB HID, which will allow the microcontroller to act as a USB human interface device. We then import digital I/O. This is used to control the digital input and output of the pins, so in other words, our keys. Then we import time, which will provide time-related functions if we need to make a short delay. We then import the Adafruit HID library. So key code, this contains all the key code for the keyboard actions. Keyboard, this allows the microcontroller to send keyboard inputs. And then we can also import the layout, and we will use the US keyboard layout support here. And then consumer control will allow us to control media functions like volume, play and pause. We will then set up our consumer control and keyboard. And we do this by saying cc is equal to consumer control. This creates an instance that will allow us to send media control commands like volume control. And then we have keyboard, and we set up the instance that will allow us microcontroller to send keyboard inputs. And then for the write text, we are using the keyboard layout US. This object helps in sending text in a US keyboard layout. We then set up the OLED display, and we start by releasing the OLED display. So this will release any previous resources used. And then we set up the I2C configuration. The SDA and our SCL, these variables will define the I2C data clock pins and for the microcontroller. Then for the bus IO, we initialize the I2C with specified pins. Then we have our I2C display, which we create an I2C display object for the SSD1306 OLED display. And then we initialize the display with the width and height of the pixels. Then we create a display context, and we use the splash with the display io.group, and this creates a new display group that can contain multiple display elements. And then display.show, this will show the created group on the elements. We then set up the background, and we're using a bitmap that will create a bitmap with a specified width, height and color, depth here in 1 bit. And then we have the palette that defines the color palette for the bitmap. And then tile grid, this will create a grid to display the bitmap on the screen. This is used to add the background. We then create a label text with specified font, and here we'll just write Nerd Cave, and then we will write this to the text area that will add the text label to the display group. We then go set up the buttons. So first we'll create a button definition, which will just be a list of the GPIO pins that we need to create the buttons. Then we will set it as a digital in-out, and each button pin is set up as a digital input. And then for the pull-up resistors, the buttons are configured to use internal pull-up resistors, which means they will read high when not pressed and low when pressed. For the mode change button, it is a similar setup which we have done for the buttons on top. We then go and set up the router encoder pins. The clock, the data and switch pins are defined and set up similar to the buttons. This will allow the microcontroller to detect the rotation and the pressing of the router encoder switch. We then set up the router encoder variables. Previous clock value will store the last state of the clock pin. To detect changes, we will use a counter, which will be a variable to keep track of how many steps the router encoder has moved. Last rotary time records the last time the router encoder was turned to manage timing. We then set up the mode names, and this will just be a dictionary mapping the mode number to the respective application names. And then we initialize the current mode, which in this case will be Blender. This here will be the most important part of the program, and here we define the macros for different modes. So each mode has a list of lambda functions that define actions for the button presses. So when a button is pressed, the corresponding function is executed. So here we have for the first 5 buttons, so you still just need to go add 3 more for buttons 6, 7 and 8. And you will have to do this then for each mode. So here you can use that documentation of the HID library, and here you can then send different key codes. We will then set up the rotary encoder actions for the different modes. So similar to macros, each mode has actions defined for clockwise and counterclockwise, as well as the switch button press. In the main loop, we will do the button handling. The main loop will continuously check for button presses, and when a button is pressed, it executes the corresponding macro for that current mode. Now let's just run the code and have a quick demo of the macro keyboard. Here the code is running and it shows on a screen Blender. Now if we go to the Blender macros, let's see what macros do we have defined. So for the first button, we see that's going to decrement the volume. So let's press the first button and you'll see there on a desktop, the volume is decreasing. Now if we look at the second one here, it's just going to be plain pause, so I don't have music running now. And if we look here at button 4, this will increment the volume. So if I press this will increment it. And then this one, button 5, will send the key letter N. So let's maybe go put the letter N here just to show here. So you'll see when I press here, we send the key code N. And then here, if we press button 9, it will then change the mode. So now it shows mode change, and now here it will show Windows. And we can also go check the rotary encoder. So if we go down on the code, we see rotary encoder here. This will be up or down arrow, but let's go back to Blender mode, because then we can control the volume. So here is Blender mode, and you'll see if I turn this, the volume will go up, and if I turn it anti-clockwise, the volume will go down. So that is just a very short demo. So like I said, you can go play around with this. Look at different key codes. We'll just need to go remove this again, and it will be very easy for you to set up to make your own custom macros. And that is all for part 1. In part 2, we are going to make a custom PCB for this, and we're also going to 3D design an enclosure. If you are interested in that, make sure to subscribe for the next part. I will see you in the next video.